two like short sections. They're very short. They're not necessarily related, but since they're both short, it's better for a test. And they're not very difficult. So first we start off with families of functions, and we actually know most of this stuff. We're just going to also apply it to a different function that we worked a lot with last year. So this year we've been spending most of the term sheet on quadratics, right? Quadratics, when we start with quadratics, we learn vertex form. It's really nice because we can see A, H, and K. So vertex form is y equals A times x minus h all squared plus k. Okay. Yeah, we went over a lot. It's been a few weeks, maybe even over a month since we went over A, H, and K. But can anyone remember what we would write under H? Opposite, okay. Opposite, and that's when we write same. Does anyone remember what they do to the graph? What is it? I was like, I hear this. Where's going to go? And this one is horizontal shift. This one is vertical shift. And horizontal shift, essentially, if it's inside the function, it goes opposite of what the sign is. The outside function is the same direction. Yeah. What are the two ways to write after G? Okay, now A, the multiplier, does a lot of things. Okay, so we list three different things that A does. Who remembers one? That's a long time. How long is it? 7? Okay, what is the flip? When A is negative. So when A is less than 0, the graph is effectively a vertical flip. We don't do horizontal flips, but this year maybe. It would be a vertical flip. Down. Okay, so we have a vertical compression, a vertical stretch. Do you remember which one's the vertical stretch? In the slope, right? When you run more or when you rise more? Margin one, right? Because rising and run, going up when you're going out, it's a stretch. So when A is greater than 1, it's a vertical stretch. And the compression happens when A is what type of a number? A fraction that's, the fraction could also be greater than 1. But it has to be a fraction that's between 1 and 0, 0 and 1. If it's less than 0, that just means it's going to flip the graph, and it can still be a vertical stretch. If it's the absolute value, we should probably say the absolute value of A. And we should probably say the absolute value here as well. But we can still have a vertical stretch if it's negative, if it's smaller than negative 1, yeah? Yeah, you're right. I did that the wrong side. Thank you. Okay, and yeah, that is really the one thing. Okay. So, what was the function you learned about last year? Exponential. Okay, I'm actually going to space blank for a moment. I'm going to come down here and give you a couple examples. I want you to see what happens with your calculator. Let's do Well, that's not the one I wanted. This is what I want. Oops. Okay, what's the difference between these two functions? Y equals 2dx plus 3 versus y equals 2dx minus 1. What's the difference between those two functions? I'm going to start with it. One has a plus 3 and one has a minus 1. So every calculation we're just going to see what happens, what's the difference. And the parent function would be the most basic function. So the parent function, oops, I can't see everything you need. The parent function in this case would be y equals 2 to the x. And then we have a plus 3 and a minus 1. If we make any hypotheses about what the plus 3 is going to do to the graph. What do you think this plus 3 is going to do to the graph? Think it out. What do you think the minus 1 is going to do to the graph? Okay, and then see. So go to y equals to the calculator, run our calculators. And let's type down the parent function so you can see the original. 2, the parent button above the division is your exponent parent x. Go down, let's put 2 parent x. Make sure you're out of the exponent before you push plus 3. 2 parent x, make sure you're out of the exponent using the arrow if you need to, minus 1. So we have three functions. We have our parent function, and then we have, and again with plus 3, and then again with minus 1. To make sure your window is normal, you can go to Zoom and then pick Z standard, and that will automatically change your window to a standard window rating 10 to positive 10. Or you can just hit graph if your window is good. Then hit graph. Here's the parent function. Is it actually exponential? Because the x is in the exponent, so it's exponential. The red one is the plus 3. I think I can pause. Okay, pause it. Hit the red one back, shift up. How many uses shift up? You can look at your calculator. Oh, I didn't pause it. Dang it. Let me make this bigger. Size large. That's not large at all. This is big enough to get mine. So you should have what you want. How many units up did it shift? Look at the y-intercept. Did the y-intercept actually shift up 3? Yes. Okay, look at the bottom one. The bottom one is the minus 1. Did it actually shift down 1 from the original? Yes. So you can deduce that when you have a plus 3 or a minus, plus or minus after the exponent, what type of shift is that? A vertical shift. Will it go the same direction as the sign? Same. Okay, so now I'm add more to it. Example 2, I'm going to take off the river shift now. But if I do y equals, here's my parent function still. Y equals 2 to the x. It's my parent function. And then y equals 2 to the x plus 2. And y equals 2 to the x minus 1. Any hypotheses about what this plus 2 will do to the graph? Daniel? Okay. Do you read that? So -1 might make the rise less steep. Okay, I'm going to actually use, because that was too small to look at last time, use this camera. Maybe it's a bit, no, that's going to freeze. I probably shouldn't turn that on. No. Yeah, that was a bad move. That just froze. Spinning world death. Dang it. Okay, I'm just over it. I know I just wrote, so, ooh, is it really over it? No, it didn't recover. Okay, so what was it? Y equals 2 to the x minus or plus? Plus 2y equals 3x minus 1 divided by the hand function. Okay, so go back to y equals, your sensor on your screen too, so you can see it. 2x is already normal. Now this one, if you have the old calculator, you need to make sure you do parentheses, so your calculator knows I'm going to do parentheses x plus 2 closing parentheses. So the calculator knows that everything in these parentheses are both in the exponent. Technically, which right now, I don't have to do parentheses because the body formats are funny, but most of you, if you're using them, I have the old versions. So compare it, parentheses, x minus 1. So calculator knows, oops, I missed my parenthesis. So I can insert a parenthesis. So calculator knows that both of these are in the exponent. Now it's ready, press graph. And the first one, if you type it in that's one on the board. Actually, let me just change my window. I'll have to play with this done. Okay, I'm going to change my window a little closer. Oh, that's a negative 20. No wonder it's so small. What's this negative? I did this negative, that's why. Okay, so there's the first one, that's the bigger function. Next in there is the one that's plus 2. Oh, what happened? It came out earlier, and here comes the minus 1. Did it come out later? I don't think the steepness has changed because if you look further to the left, it's all the same steepness of the curve as the same shape of curve. But what's happened this time? The horizontal shift. That makes sense because it's inside the function. The red one was at plus 2. The horizontal shift of blue curve was shifted left. Why was it shifted left? It was the right, it was plus. Opposite. And the black one was minus 1 shifted to the right. 1, so it came out of the later by 1 unit. So inside the function again, is horizontal shift, opposite. What happens if I gave the 2 multiplier in front. Or that was a negative multiplier. No, it is. If we multiply in front with a negative. But you all do the negative sign. It's going to flip. If we behave the exact same way, I don't have it up there anymore. So on our graph, we had written quadratics. We had written y equals ax minus h all squared plus k. Horizontal shift, vertical shift, opposite, same. And then we wrote for a, three things. Well, exponential behaves exactly the same. Actually, all of our functions behave exactly the same. This is why we expand the whole term on quadratics, because all of the properties of transformations that happen in quadratics also happen in all of our other functions. So exponential, and even last year, we did write in y equals a times b to the x minus h plus k. B stands for the base, because we have a base and then an exponent. Okay, so we just found what h does. If something in the exponent added or subtracted, how does it shift the graph? Horizontal shift. Same direction of the sign. Opposite. K. What's the K do outside the graph? It's officially no exponential. Vertical shift. Same direction of the sign. And A, we didn't look at the graph of A, but we can deduce that it's also going to follow the same as quadratics. If A is less than 0, it's going to flip vertically. If the absolute value of A is greater than 1, what type of vertical shift or compression would that be? Or stretch or compression? Stretch. Vertical stretch. And if the absolute value of A is between 0 and 1, that would be a vertical compression. Okay, so I'm going to be assigning you this lab in the book, which you already know the answers to most of these, and you could have answered them like a month ago. And she says, what do you observe when K is positive? Well, when K is positive, it's in the same position, so if K is positive, what happens to the graph? It vertically shifts up. What happens if K is negative? It vertically shifts down. So that's what we say. When K is negative, it vertically shifts down. What do you observe when H is positive? We can answer that. What do you observe when H is positive? Horizontal shift left. When H is negative, horizontal shift right. So we can answer those questions. What is the effect of the shape of the graph when, this is one I have not done. This is one difference. This one has an extra variable, B. Oops, I'll do that. Let's look at two different things. B, the base, can either be an integer or a fraction. Let's look at two different graphs and see what happens when we change B. What happens with B? Okay, let's do, we've already done 2 to the x, let's keep that the same, versus y equals 1/2 to the x. Let's see how those graphs differ. Having an integer base versus a fraction base. Grab your calculator, type it in, and see what happens. We should already have 2 b's in, but this time, y cubed from parentheses 1 divided by 2, close the parenthesis, all raised to x. And look at the graph. What happens when your base is a fraction between 0 and 1? It can also be a decimal between 0 and 1. Whoa. So you should have marked this last year, but it's been a while. So if I push graph, I'm pushing the minus heat line 3 times. And the second one, the red one, is going to have the base of a fraction where I'm going to write 0.5 to the x, so between 0 and 1. What happened to it? It decreased. So the blue one's called an exponential. The exponential growth. The red one, when we have a base of a fraction of something between 0 and 1, it's an exponential decay, is what that's called. Exponential decay. So on our base, when b, absolute value of b is between 0 and 1, it's an exponential decay. When the base is greater than 1, it's an exponential growth. Okay, so in your book, I think you already know everything there. So what is the effect when the absolute value of b is between 0 and 1? What would you say? What's the effect when the absolute value of b is between 0 and 1? It's an exponential decay versus what's the effect of the shape of the graph when b is greater than 1? Exponential growth, yep. It was on page 125. Okay. Right, so now you can do all those in all the shiftings. So we're going to pull in some spheres, so they're not technically related, but they're two things that are easy, so we can squish them into one go. We're going to shift gears over to 4 combining functions. As we go to the second central question that comes in that says, what are 2 ways to write f of g? Combining functions happens when you're given multiple functions and you have to perform operations on them. So to start with, I'm going to try to avoid the I'm trying to avoid the exponential answers here. So, I was really tired. I can use those ones. Given f(x) equals 5x plus 2 and g of x equals 3x squared. Okay, f of x is what type of function? X to the first power is a function of that. Linear, it's like a line. G of x squared is what type of function? It's not exponential. Exponential is with x and the exponent. This is a quadratic. So all we're going to do is perform different operations on them. F plus g of x. It's pretty straightforward. We take f and we add g. So I take f and I add g. Okay. And then I just make sure my answers are in the correct order. Okay, Will, what would the correct order be? Stand x1 down to lowest x1. So cross 5x is positive. There you go. So that's the sum of f plus g. Okay, what about f minus g? Can you do something to that up? This is written f minus g of x. This is not times x, it's of x. What's the f function? 5x plus 2. Now you have to make sure you subtract everything of the next function. In this case, it's only one term, so it's not so bad, but if there are multiple terms, make sure you have parentheses. 3x squared. So we get standard form negative 3x squared plus 5x plus 2. I'd like you to do the reverse of that. Reverse it. Now do g minus f. G minus f of x. You should have a minus when you subtract everything that's in that second function. So remember the same, what are we doing to you? Let's see. We'll make sure we minus everything. Good, that's right. Okay, so you should have written what is right for g minus f. Parentheses, good job. Okay, excellent. You're going to subtract everything, which means that 5x is actually going to be minus 5x, and 2 is actually going to be minus 2. So we have our answer, we have 3x squared minus 5x minus 2. So we make sure we subtract both terms. Okay. Now, let's add another layer of difficulty. Let's keep it the same one we did. It's just a g minus f of 2. What's different this time? We plug into x is 2. So we've already done g minus f. Okay, so we'll do that first step, which we have this. But in place of all the x's, x is 2. So it's one extra step that you're evaluating at the x value they give you. So if all the x is just an x, then you just do the operation, make sure it's in order, and stop. But if x is changed to 2, it's not times everything by 2, it's of 2. So you evaluate with x being 2. And then you have to go to your order of operations. Okay, Catherine, what will we do first to simplify that? Two squared, good. So x was first. So that would be 3 times 4. Okay. Oh, then what next? So the multiplication, yeah, I think I can actually do both versions of trying to do the same step, right? Because it's the same operation. So 3 times 4 is 12. Negative 5 times 2 is negative 10. Let me just subtract. 12 minus 10 is 2, minus 2 is 0. So if we get a number, we have to do one more step and plug it in. Okay. Now, next operation. Now you have to be careful about how this looks. If the dot is filled in, that means times. If it's open, it means something else. So this would be F times G. F was our 5x plus 2 times G, which was a 3x squared. Okay. Let's see, how do I multiply those? Yep. And what do you get? What do you get when we distribute that in? Good. Good. And again, if we have a number here like 4, then we don't plug in the 4. And then we work it out. Okay, I'm not going to do that right now because I just want to move on. But if there's a number there, you have one more step. Okay, we have another division. Ooh. Okay. Make sure you always pay attention to the order. I'm trying to mix it up. It's not always F first and G second. In this case, G. In this case, which function's in the numerator? G. What is G's function? Good. So that's what's in the denominator. 5x plus 2. Can this simplify? Can I cancel the x's? Take one off here and one here? No. Only if it's multiplied. If it's added, no, you can't do that. So that's as far as this can go. Okay, now for the one for the essential question. Remember I said this is filled in? When it's filled in, that means multiply. When it's open, it looks like they're a frog. I don't use this one very often. It seems like people like the other format. I like the other format of this because it's easier to see what the role of this is. But if it's open, it means the same thing as this. It's not times, it's turkey and stuffing. We have F, for turkey every time for Thanksgiving, stuffed with G. F is on the outside, G is stuffed inside, and it's read F of G of X. F of, so it's not F times G of X, it's F of G of X. So essentially, turkey, the outside is F. The stuffing, stuffed with G of X. Okay, so if it's an open circle, that's F of G. So we're going to take F. What is the F function? 5x plus 2, but 5, we're going to stuff where the X is. It's the only place we have to stuff, right? And inside the X, we're going to do the stuffing. What's the stuffing? 3x squared. We multiply the 3, we get 15x squared plus 2, which is different than multiplying. Okay, last one. If the turkey loses the stuffing. If the turkey is on the outside, the stuffing is F of 2. So we start with the outside, the turkey. G was 3x squared, but with the x's, put big parentheses. G is df, which is what? 5x plus 2. Now, so you're so compound right now because the x, I think less work if we just put the number in right away. What should the x be? 2. And we have to perform what operations on that. We need to do parentheses first, right? And inside the parentheses, we have to do multiplication, which is 10, before we add. Then we have to finish the parentheses by adding, which is 12. And we have to square, and the last step is multiply. So we get 3 times 144, and I don't know what 3 times 144 is. What is it? 432. Thank you. Okay, so there's the number here. Replacing the x. The last step is you need to insert that number, so it's an extra stepping. So that's what I actually call chur, dunk, and Dunkin'. What's Dunkin'? Turkey stuffed with duck, stuffed with chicken. 3 layers. Turkey covered duck, stuffed with chicken. Anyone ever actually had a Dunkin'? I've never had it. Turkey stuffing, look at what's on the outside is like stuffing, and what all the stuff with the X's are. Okay? So, put your homework calendars, or your planners. If you need a homework calendar, there is a extra copies over there in the corner of the board. So, homework is coming from 2 different sections. Okay, page 124, 1 through 10. That's what we started with. Page 124, 1 through 10. This one. Okay. Okay, I don't like that. What's in your honors book? You look really quick in your honors book. Okay, on part 4, I'm going to add in a couple extra problems. I'm changing because those do exponential ones that are in the book, and they're just awful. So I'm trying not to make it awful. You're going to do, it's on the review part in page 295. So that way it's just 2 linear functions, which is way nicer. You need to do 24 to 28. That only takes you to add, subtract, and multiply and divide. So I want you to also add in, we need to also find 3 more. F of G, G of F, and F of G of 2, and G of F of 2. So add in 4 more problems. Okay? And study for your test. That's just volume 1. So I forgot that you supposed to do lines that doesn't have to be solid or open. I did all correct. But in this country with the microphone, so I can't even correct it. I don't care Okay. I'm going to actually get ready tomorrow because I'm going to have to run to Little Next to the after school. Thank you. Hmm?